So the challenges that comes with accelerating data lake house queries, right? Um, so the main challenge, the biggest cost of data lake query is actually fetching the data, metadata, from your external data lake and data lake house um, storage, right? So first is the network overhead that comes with it, right? It has to go through network, and that's that does not only make the processes slow, but it also affects query execution as well, because any like query engine that does join or high cardinality aggregation, they do data shuffling at query execution, and that process needs network IO. If you take all of the network IO, like reading external data, that can really hammer the performance of your query engine and makes it insanely slow, right? And also the slow and unpredictable performance of data lakes. Data lake, you're not the only one that's using it, right? And that can, the latency and the IO can be very unstable. And also, data lakes are on slower storage devices, HDFS or cloud object storage. Let's take S3 as an example, right? Latency of S3, AWS S3, can be more than 100 milliseconds. But on an NVMe SSD, you can get that sub 10 milliseconds easily, right? And so data lakes itself is slow to scan, and also your data files can be inoptimized for query performance, right? If it's not compacted correctly, they can be small files scattered, and that's horrible for scanning, right? For querying, for OLAP queries, right? And this whole fetching data problem has becoming even more severe with query engines now run so much faster, right? So the faster the query engine run, the less stress is on the CPU, the more stress is on the IO, right? So when query engine run faster, IO becomes more of a bottleneck, right? Even with really complex CPU intensive queries with really large scale joins and high cardinality aggregations, right? That's supposed to be heavy on the CPU, but now on the IO because of these challenges. And also, getting fast queries is not enough, right? We still need to to build ETL pipelines to further accelerate the queries, right? To do pre-computation, uh, pre-aggregation, and denormalization, right? Just by storing the result of a query, right, as a separate table or field, right? And then query that to avoid on-the-fly computation, to avoid denormalization, to avoid on-the-fly joins, and pre-aggregations to avoid on-the-fly aggregations, right? Let's take an example here, right? Let's say you're using Spark to do that pre-computation job, and that's common, right? Let's say your data user identifies a slow query and it reports to you. You're the data engineer, right? And you add a pre-computation to your pipeline. That can be a denormalization pipeline that joins all of the tables and creates a flat table, right? That contains the result of the join, right? But that's not the end of it. It's not going to take effect until your SQL script is rewritten to point to the new denormalized flat table, right, for it to take effect. And that rewriting process is a big pain we see in the field. That forces the data engineers, to figure out all of the data pipelines, pre-computation pipelines prior to the data user or themselves developing the client-side application, right? SQL scripts, right? Because that's such a big pain, rewriting the SQL to point to the new table. Nobody wants to deal with it. So when they build the pipeline, they build a little more than they need. So that end up with generating pre-computed tables and pre-computation pipelines that never get used or very rarely get used, right? So a lot of waste of labor and computational power. resource, right? And that significantly, this whole planning process significantly lengthened the development process, right? With a lot of experiments and understanding of your SQL and understanding of your data, right? And anticipating what the growth of the system is going to be, right? That takes a very long time. So you go to production a lot slower with the current ETL pipeline, pre-computation pipeline for query acceleration, right? And the reason for this is because query engines are running much faster now, right? And ETL pipelines are not really catching up with it. So before, query engines are fast, they were slow, right? A common practice we see in the field is that you have a Spark cluster that basically pre-aggregate and denormalize everything, right? And send the all of the pre-computed result to even a KV store or a transactional database that only does serving. So there is no like um, OLAP compute at query execution, right? Um, so when you basically default to pre-computation to everything, this is not really big of a problem, right? But as query engines are running so much faster, people now have the option to do on-the-fly computation. But this ETL pipeline is not really suitable for that, right? And that's where we see the huge mismatch, right, of these two.